Today's objective is our last of this unit. It is to informally prove the properties of points on an angle bisector by constructing a bisector of an angle. And in class, you're gonna use a compass and a straight edge, and there's gonna be some more complicated problems. But for today, for this procedural fluency problem that we're gonna do right here, you don't need any of that stuff. So we're gonna sketch a figure. We are going to write some equations, and we're just gonna make sure everything is labeled and marked correctly. So the figure that it says to sketch is angle ABC. So you should have some blank space on one side. Can you draw in angle ABC? Keep in mind an angle has rays on either side. So I'm going to put in point A. Point B is the vertex. And then point C is on the other side of the angle. And then it said it's bisected by BD. Now bisect means it's on the interior. Ray BD is on the interior of this angle. And it also, of course, means that the two angles that are created by bisecting ABC are congruent to each other. So it doesn't matter how you mark these, but just like with segments, you have to mark them somehow using the same amount of angle symbols or tick marks. So I use like a double angle, but you just use whatever you like as long as you do the same thing for each one of these. This is now a picture of a bisected angle that is marked correctly. Next is to write the equations, and there's two equations that are created here. One from angle addition, which we did earlier in this unit, and then also from the definition of bisection. So angle addition tells us part plus part equals whole. So that means the measurement of angle ABD added with the measurement of angle DBC, you notice that's part plus part, equals the measurement of the entire angle, which is the measurement of angle ABC. So this is one equation that you might need to solve for angle measurements. And then the other one comes from the definition of bisection. So bisection tells us that the angle ABC has been cut into two congruent angles, which means the measurements of these angles are equal to each other. So our other equation is the measurement of angle ABD is equal to the measurement of angle DBC. And that is it. The procedural fluency for this objective is to sketch, mark, and write equations for an angle bisector.